Today, we're very happy to welcome Professor Grant Abt, who is an exercise physiologist and former professor of exercise physiology at the University of Hull. I'm just trying, yes, I have started recording. Grant's PhD is in exercise physiology. He has published on matters related to physiology of team sports, wearable technology, and research design and statistics. And Grant has been an editor at the Journal of Sports Sciences since 2012 and is currently the executive editor for registered reports. And Grant is obviously an advocate for open research, and until recently he was the UK Reproducibility Network local network lead for the University of Hull. The talk is going to be on ethical implications and on a discussion on ethics applications for research practice and potential solutions in the context of open research. So as almost all research on humans is considered by an institutional research ethics committee prior to data collection, when evaluating research proposals, ethics committees must balance the benefit of the findings and the risks to participants. And from a risk perspective, ethics committees usually consider physical and psychological harm as the main criteria. Grant and others argue that a poor study design, including studies underpowered to detect meaningful effects and those using questionable research practices, also constitute an ethical issue, because studies that are not designed appropriately to detect meaningful effects constitute research waste, both for funders and participants. And today, Grant is going to talk about the role of ethics committees, aspects of research design and statistics, the so-called replication crisis engulfing many scientific disciplines, and potential solutions to these problems. So without much ado, I will invite Grant to start the talk. Hi, Grant, and thank you for joining us today.
Thank you, Shafag. I think you've summed up my entire talk in 30 seconds, so maybe we can just go and have a coffee. But yes, so as you can see from my list of what I've been doing, I've been around for a while, and up until last year was a professor at the University of Hull. But I was in my career up to that time, and particularly at Hull, I was also somebody who regularly reviewed ethics applications. And so my talk today is one that I've given previously at Hull. And it really came out of the experience of reviewing applications with my kind of open research hat on, my statistics hat on, and all of the problems that I was seeing in these applications. And so from that experience, I wanted to argue inside the university that we need to do something about study design at the point at which these ethics applications come across our desk. Because if you're familiar with the registered reports process, maybe the best thing about registered reports is that the feedback from reviewers means that you can do something about it before you undertake the study. And I argued, and I still argue, that the ethics application is a really important gatekeeping position that reviewers are in to, yes, address the ethical issues, but also to help researchers improve their design. And that also includes the statistical analysis plan. So it's a key moment in the process of doing research. Okay, so why are we talking about this? Well, as I just mentioned, this is a typical page from an ethics application in my department at Hull. And it asks how many participants will be recruited. And in the red box there is a typical response that I would say random number recruited from the local population. And it also asks, do you have a power calculation? And usually, as the graphic shows there would be tumbleweeds. There would just be nothing there. And so as a quantitative scientist, and I have to say that all of the talk is about quantitative research. I used to have some aspects of qualitative research in there, but just for see on your YouTube channel that somebody gave a talk on pre-registered qualitative research a couple of months ago, so refer. But yeah, this is a typical application I would see, and if there was some sort of consideration of sample size, and in this case a power calculation, it would just essentially be reiterating the sentence above, you know, with no details, no justification. And so that's a real problem, and I'm going to try to argue why that's a problem. And this is, with my editor hat on, this is typically what we might see in the resulting paper that's published. Following Institutional Ethics Committee approval, okay, so what is in the application that you've just seen has been approved by the Ethics Committee, then, you know, 24 adults, 12 people per group volunteered to take part in the study. So the authors are saying the Ethics Committee has signed off on this, okay, because it was in the application. And I believe that is an issue in itself, is that if Ethics Committee have given approval for this method, then they have to take some accountability for that. 5 years ago in 2020, as I said, I'm an editor at the Journal of Sports Sciences, and we wanted to take a stand on this issue of underpowered studies. And so we wrote an editorial, and we did a small audit of papers being published in the journal. And of 120 papers, only 12 included a sample size estimation, so 10%. And then we gave some recommendations for how authors should do that. We've just a few weeks ago published a follow-up editorial where we've mandated the inclusion of a sample size estimation in manuscripts. And as you can see from the table, the number of manuscripts including a sample size estimation has gone up a little bit. But those, if a study does include a sample size estimation, it's very poorly done. And you can see that on the right-hand column. All input parameters for the calculation have been reported. Less than 10% of the papers fully reported how they came to the sample size. And so the issue of sample size estimation, in my view, is at the heart of doing quantitative research, because of the implication that has on your results and the claims that you make from your data. So as Shafak said, a lot of this is rooted in the so-called replication crisis that kind of originated in psychology about a decade ago. And I really like this tweet from the health nerd a couple of years ago, showing you your typical meta-analysis plot there. It's hard not to look at a forest plot like this and not feel like the entire exercise of science has failed here. Decades of tiny useless trials instead of a handful of big useful ones. And on a similar note, from Richard Lehman, need for meta-analysis is often an indication of failure. Tiny useless trials are always an indicator of failure, and crucially, an abuse of patient trust. If ethics oversight was fit for purpose, they could not occur. So clearly, people other than me are thinking that this is not just an issue for doing science, it's also an issue for ethical oversight or ethics oversight of how we do research. And just to illustrate the influence of this, I don't know what your knowledge of statistics is, but I'll try to explain this as best I can. Typically, in the quantitative sciences, people using what's so-called frequentist statistics will probably do what's called a power analysis. before they undertake the study to determine how many people are needed to detect an effect size of a given size. And the typical relationship between effect size and sample size is inverse, in that the smaller the effect you want to detect, the more people you need in your study, and vice versa. So if you want to detect a really big effect, you don't need as many people. And so on the left is software called G-Power, which allows you to calculate this this value. But you can also do what's called a sensitivity analysis, which is kind of reverse engineering the calculation to say, if I have a certain number of people in my study, what's the smallest effect size that I could detect? So with a sample size of 19 in each group, which is what we found in our original editorial, so on average, a typical Journal of Sports Sciences paper was had N of 19. So this is actually, you know, better than that, because this is 19 per group, because it's an independent design. But for an independent t-test, if you have 19 people in each group, you can detect, the smallest effect you can detect is about 0.9. And on the right-hand side is a distribution of effect sizes from the strength and conditioning literature. This is from a meta-analysis. So they've developed a distribution of all of the effect sizes that have been reported. So that effect size would be classified as a very large effect. So it's kind of equivalent to the medium and the large effect sizes put together. Okay, so you know, if you're only interested in detecting large effects, then a small sample size might be okay. But that's typically not the case. And in my particular field, sport and exercise science, we've known this for a really long time. And this is a paper from 25 years ago. So just let me move this out of the road so I can read it. So in researching elite athletes, some intervention, training regime, or nutritional supplementation that improves times or distances by 0.5% could translate into quite significant results. Those significant practical improvements, however, would not, in much of the current research, reach statistical significance. Okay, so we knew that 25 years ago, and it's you don't have to be a sport and exercise scientist to know that, you know, if you're watching the Olympic Games, the person who wins often beats the person coming second by a very small margin. And so in my particular field, small effects are really important, or can be really important. But there's also the opposite. What are the costs of a so-called type 2 error? That's a false negative, where you fail to find the effect that's actually there. In the case of a small, statistically non-significant but practically important result, the cost may be that an effective treatment is deemed ineffective and athletes will not benefit from it in the future. And of course, an error is entered into the literature. And in my view, participants' time and resources have been wasted. And this is part of the ethics application process. Remember the benefit versus harm. What is the benefit to harm ratio? And in that harm aspect, I would include the burden on participants. Okay, so at the heart of this is low statistical power. And we can see this very easily in simulations. If you want to have a go at the simulation, I've written this little shiny app that you can test out the power of doing independent t-tests. And in this particular simulation, each time you run it, you're doing 10,000 simulations of an independent t-test. And so you can set the parameters up here on the left, 80% power, sample size, and the effect size. And really, the figure shows us what power represents. If we were able to repeat a t-test 10,000 times, if we want a high probability of finding the effect that's really there, because it is really there in a simulation, we can make it be there. Okay, what we would expect is for 80% of those p-values, the outcome of the t-test, to be less than 0.05. In this particular case, with 15 people per group, okay, our achieved power is only about 25%. So only 25% of those p-values have detected the effect. The other 75% are suggesting there's not no effect, but you're failing to reject the null. What happens if we were able to do that? Well, as you can see in the box, the top right-hand side, it would require 65 participants in order to do that. So if we run the simulation again with 65 people in each group, now we see that about 80% of the p-values are lower than 0.05. Okay, we still have 20% that aren't, but these are the parameters that we typically set before a priori we do the experiment, and that's all the power is about. It's about the long run probability of detecting an effect if the effect is there. And most of the studies in my discipline, and probably in yours as well, are more like this than like this, and that's why it's a real problem. And not only sorry, I'll just look at this slide here. So again, we've known this for a very long time. This is from 1972, okay, so over 50 years ago. And this is from the Research Quarterly journal. Powers calculated for different effect sizes were disturbingly low. That's not a phrase you'd want to hear, really. So the power for detecting small effects was 0.15, medium effects 0.54, and large effects 0.83. So even in those days, most research was only powered to detect so-called, inverted commas, large effects. Medium and small effects, you had a very low probability of detecting them if, in fact, the effect was there. And that's a real problem. So when researchers analyze a small effect with a small sample, analyses are underpowered. Underpowered analyses are highly problematic. First, they reduce our ability to find effects that actually exist. That's the so-called type 2 error. Second, they overestimate the size of those effects that are found. We know that this is what's colloquially called the winner's curse. If you do have an underpowered study and you find a significant difference between groups, it's likely that that effect size, the size of that effect, is larger or inflated compared to the real effect. Okay. So not only do you have a high probability of not finding it, if you're lucky enough to find it, you will overestimate the size of that effect. And we know this from replication studies. We know that high-powered replication studies reduce the effect size. You can see on the left-hand side the original studies and the effect size. The median effect size is about 0.3 something or other. 0.3 to 0.4, with high-powered replications, that median effect size is now falling quite dramatically. So we know that underpowered studies, small sample studies, inflate the size of the effect that you detect. But it's not only that. In statistics, when we do a power calculation, of course, we're trying to determine the number of people we need to reject the null hypothesis for a certain effect size. That doesn't mean that if we find a significant difference, that the effect that we think we've found is a precise estimate of the population value. And we can show that again in a simulation. If we have two groups, each with n of 20, okay, and we know there's a difference between the two groups, and we do a t-test, yes, the p-value is less than 0.05, but if we look at the confidence interval for that difference, we can see there's about 20 units difference between the highest value and the lowest value. And we know that the true population value can be anywhere within that interval. In fact, it can also be outside of the interval. But just for argument's sake, when we increase to 200 in each group, yes, our p-value gets even lower. But what happens to our confidence interval? Our confidence interval shrinks dramatically. And so small samples, not only have a higher probability of making a type 2 error and a higher probability of inflating the effect size, but you also have uncertain effects if you detect them. With a high sample, high powered and high precise study, our population estimate, which is ultimately what we're trying to determine, is much more precise. And so I and many others argue that it's not just about having a sample that is large enough to reject a null hypothesis, but it's also about our population estimates. How certain can we be about what the true effect, inverted commas, true effect is in the population? And so a lot of people, a lot of researchers in my field, probably yours, are asking, is there an effect present? What they should be asking is there an effect present? But if so, what is its magnitude and how much uncertainty is there in our estimate of the population value? And we've long known about this, that researchers should not just rely on statistical significance, but also measures of effect magnitude, and in my view, more importantly, population uncertainty. Effect sizes have been recommended for many, many years, and in my experience, most authors now do report them. But the problem, I believe, is uncertainty measures. And in frequentist statistics, that's the confidence interval. In Bayesian statistics, it's the credible interval. Similar kind of concept of quantifying uncertainty in the population value. And I argue that we need to move away from this notion that statistical significance is just the be all and end all. It's not. It's one of the starting points, and that of equal importance is how big the effect is. Is it big enough to have a meaningful effect in the population? But also, what is the uncertainty around that population? And of course, we've seen all the headlines about the replication crisis in various fields, including psychology, and my discipline has exactly the same issues. On top of that, or involved in that as well, we've got so-called questionable research practices. And I believe harking, hypothesizing after the results are known, is one of the most pervasive. I see it all the time in manuscripts that come across my desk. It's clear that the authors have changed what they originally thought based on the results of the study. And it's not being transparent, which is a real problem. P-hacking, sort of selective reporting, reporting the significant ones, not reporting the non-significant ones. I quite like this this graphic from a paper published in my field, illustrating the kind of the invisible bits and the visible bits. The invisible bits is how researchers are selecting what they report, harking, and publication bias. And then ultimately what the reader sees in the published literature, all of on the left, is kind of invisible to the reader. And I believe that's a real problem. And of course, we've got the long-standing issue of publication bias, the trend for studies that have significant results to be published more often than papers that don't find anything. And we know that this is the case from studies on registered reports, where in the standard literature, a surprisingly high number of hypotheses are supported. When we do a registered report and typically have a more robust, rigorous design, and the process of managing that manuscript is changed so that the reviewers make a decision on the manuscript without seeing the results, we see the number of supported hypotheses drop dramatically. Okay, so and that's clear evidence that reviewers, editors look at the results and base the decision to publish or not to publish on the results rather than the questions and the methods. And of course, looking really big picture, why is all of this happening? Well, there's a hornet's nest of perverse incentives and competition that are driving researchers to to do these things. And it's beyond today's discussion really to talk about those things, but we do need to acknowledge that, you know, we don't live in a bubble, and we are human. You know, we're swayed by promotion and status and ego and all those things. So what has all that got to do with ethics? Well, when we do see an ethics application like this, for those reasons, this is problematic, because in this particular case, the researchers clearly have little knowledge of good design, whether their study can answer the questions they pose. If they don't know about sample size estimation, they don't know any statistics, they're doing a quantitative study, they don't know whether their sample is able to answer the question or questions that they want to answer. And that is a problem both for them and for the ethics committee. So what is an ethics committee for? I'm going to show you some of the documents from Hull and also from East Anglia. These are all on the website, so they're all publicly available. So research ethics policy is intended to, and just look at the bit in green, direct researchers to adhere to best practice, implementation, and dissemination of research. Okay, so best practice, they acknowledge that. Research integrity, in part, applies to the reliability of results, provide value for public or private funds invested in the project. And where they say provide value, I believe that relates to the benefit element of the equation. But the reliability of results, clearly, for me, how I read this, is that's related to all of those things that I've just been talking about. And in another document from Hull about responsibilities, researchers must adhere to all policies and codes of good practice. Researchers must satisfy the Research Ethics Committee that a proposed body of work is of benefit to the participants or for science and the community. Okay, so there's a clear direction here, and in your documents as well, that I'll show you in a bit, about benefit. Okay, that benefit, risk or harm balance. Okay, but here are the contradictions. So members are not expected to consider or review the scientific principles or application of research methods of the proposed research. Okay, so they're saying a reviewer of an ethics application just considers ethical aspects, but they shouldn't consider the methods of answering those questions. But in the same paragraph, they say it is unethical to conduct poorly designed research. So there's a contradiction there. And it's not just ethics committees. You know, journals have thought about these issues, and one of the more prominent ones in my field is International Journal of Sports Medicine, and they've published a series of editorials on this over the years, and they believe, it is agreed, that both underpowered and overpowered studies can be unethical. I fully agree with the first. I'm not so sure about the second, because an overpowered study is based on power but has no consideration of precision. And I believe if you're going to err on the one side or the other, it's preferable to have an overpowered study and have a precise estimate of the population value versus underpowered. Okay, but clearly, you know, they're having this debate about, is an underpowered study unethical, and I believe they say it is. An unethical scenario is where many participants or animals have been substantially burdened by the study procedures, but the study findings have dubious clinical or practical importance. And that's really clear. That's clearly about the benefit to risk. Okay, if you're putting your participants through procedures, but the study findings have dubious clinical or practical importance, then I believe that is unethical. A study which is adequately powered for statistical significance, yet is underpowered for reliable judgments regarding practical or clinical significance, may be unethical. So this relates to the precision aspect. So you might power your study to be able to reject a null hypothesis. But that doesn't mean your confidence interval will be narrow, okay? And it doesn't mean that your confidence interval isn't going to be wide enough to include what we would call trivial effects. You might have heard of the concept of minimal clinically important difference. So this is a region around zero where the effect would be considered practically meaningless. Okay, so then they're non-zero effects, but they're unlikely to improve somebody's health or, you know, improve their sporting performance. Okay, so like me, they believe that it's not just about statistical significance. You can still reject the null, you can get a p-value lower than 0.05, but if your confidence interval is really wide and includes values that could be considered meaningless, then maybe you haven't thought enough about your study design. And this is kind of a similar thing, so I'll just go on. So some of the contradictions we see in our advice to ethics reviewers. So the application is being reviewed for its adherence to ethical principles only. The university expects all research applicants to have been rigorously peer reviewed by their research design, methodology, and scientific robustness prior to being submitted for ethics approval. Okay, so they're saying methods is not to be considered and should be done before submitting your application. But then in the checklist, we ask reviewers to comment on the method. So is the method of recruitment appropriate? Does the design and conduct of the study seem appropriate? So if the ethics committees don't review methods, then why do we ask methods questions? There's a contradiction there, and I think you know, it'd be worthwhile for you to have a look through your ethics application documents, and if you are an ethics reviewer, have a look at the checklist, and is there that contradiction? What does your ethics committee actually want you to comment on? And I would argue, and I've argued and presented this to our ethics committee at Hull, that if you're truly interested in that benefit harm risk ratio, then we do need to be asking about ethics. We do need to be asking about methods, information, and it is right for that to be part of the application. So this is from your East Anglia ethics policy, and as you would expect, you know, there are statements about maximizing benefit for individual society, minimizing the risk of harm, transparency, all good stuff and expected. But what we don't see is no mention of the ethical implications of a poor study design. So I would argue that, I am arguing that should be a crucial aspect of the ethics policy, and it should be clear to researchers that a poor design, and of course a poor design is a qualitative statement. You know, what somebody thinks is poor might not be poor, but that's up to the reviewer to indicate. But I guess the idea that methods should be part of an ethics review, I believe, is one that should occur. So I argue that a study method that has little to no chance of reliably detecting meaningful effects is unethical. It is unethical because of the burden placed on participants for little, no reward, increased knowledge. Now, you could argue that researchers learn something about an underpowered or imprecise study. You know, they learn about what works when recruiting participants, or something about the apparatus that they're using. But in a confirmatory study where you're testing a hypothesis, I don't believe that's the right place to be doing that kind of stuff. That's what pilot studies are for, you know, and feasibility studies are for. So those arguments don't wash with me. I argue that ethics committees need to explicitly state that such studies are unethical and ensure that methods review is part of their process to lower the probability of these problems occurring. So, some possible solutions for ethics committees, individual researchers, and also academic journals. The first one is methods review, and I really like this idea by Daniel Lakens, who I think I saw on your YouTube channel gave you a presentation not so long ago. So we're all fans of Daniel Lakens, which is good. So one of his one of the things that he touts is methods review. Now that could be part of the research of the ethics committee, or it could be a separate body that's solely dedicated to reviewing method. And he argues that, like I do, that that should be part of the review process. This is from the HPRA in Ireland. I found this. I was looking for information on ethics ethics committee composition. You know, who should be on an ethics committee. Now, this is related to animal research, but they are saying that the ethics committees, you know, dotted around Ireland, one member should be a statistician or a person with expertise in statistical analysis. So again, you know, look at the composition of your ethics committees and your distributed reviewer network. How many of those people are statisticians or have demonstrable expertise in statistical analysis and or research design? Yeah, and why do we want that? A person with experience in statistical analysis and design is required for most projects. Their role is to ensure that the proposed study is adequately designed and planned to ensure that the most appropriate numbers of animals are used. This is important as it will ensure the scientific validity and reliability of the results. So that's for ethics committees. Now for researchers, one of the first things for hypothesis testing studies, or so-called confirmatory studies, is pre-registration. If you want to learn about exploratory research, I'm part of a group that published with Daniel Lakens, who we just published a paper on exploratory research and how it differentiates from confirmatory studies. So have a read of that if you're not quite clear on the separation between the two. But for hypothesis testing, you've got a hypothesis and you want to test it, then I believe, and many others believe, that pre-registration is required. And pre-registration of analysis plan is committing to analytic steps without advanced knowledge of the research outcomes. That commitment is usually accomplished by posting the analysis plan to an independent registry. And in Daniel Lakens' view, and in, you know, he prescribes to the Deborah Mayo concept of severe testing, and that a pre-registration will allow your hypotheses to be severely tested. In my discipline, and the paper that I just mentioned before, we argue that most of the studies in my field are actually exploratory studies because they don't include a pre-registration, and there's too much researcher flexibility in the way that they deal with the data. And so pre-registration is a key part of testing a hypothesis. You probably know about pre-registration, but you know, that's a typical process. You get an idea for a study, you develop a method, you collect the data, you analyze the results, and then you talk about the results. With the pre-registration, there's an extra couple of steps. Okay, you pre-register your analysis plan, your method, etc., on a public repository. Then you collect the data, and then your results either confirm or don't confirm your pre-specified hypotheses. And you also have flexibility to explore the data sets, but typically those analyses need to be labeled as exploratory analyses. And we know that pre-registration does have some effect on this, and that the effect sizes that are reported with pre-registration are typically smaller than without pre-registration. It is having some sort of effect. Pre-registration can be gamed, of course, and it's not a panacea for everything, but many people believe that it's an important step. Collaborating with statisticians. Most of us are not statisticians, and one of the probably the easiest ways to improve our research designs and the ability of our studies to answer our questions is to collaborate with statisticians, and that's been argued in my field, and I believe it. I just saw this post on LinkedIn a couple of days ago from a biostatistician, and she was saying essentially that, but that if you're going to collaborate with a statistician, you do it at the start of the project, not at the end of the project. And it kind of mirrors, what she's saying kind of mirrors Fisher's kind of joke, I guess, that he said many, many years ago about, statisticians are not there to conduct postmortems on your data, and this is really important, that statisticians, people who, well, it's not just statisticians, but people who are knowledgeable in design and statistics are in the team from the start, and then they're not just there to run a t-test on your data. And I agree with all of that, but the problem is that statisticians are rare. I don't know what it's like at East Anglia, but at Hull, we had one in the whole faculty, of 500 members of staff. They cost money, and they're not just sitting around waiting for you to knock on their door. They've got their own research to do. And the final point is a really important one, that they are not a sport and exercise scientist. They are not a psychologist. They are not somebody who knows about business. They're a statistician. And there might be a disconnect there between their knowledge set and your knowledge set. Okay, so the ability to talk to statisticians, I believe, is a really important part of this. And so, yes, collaborate with statisticians, but I believe it's important for us as individual researchers to improve our statistical literacy and ultimately our thinking. Okay, and in that way, we win both ways. We increase our own knowledge about why all of those things that I said are problems are in fact problems, and how you can change your design and your statistics to improve that. But like I said in the top right hand of the slide there, it means you'll be able to talk to them on a more even keel. If they talk about power and you don't know what power is, you're just accepting that they know what they're saying. Okay, so increasing your own knowledge is a really important part of becoming a better researcher, I believe. And so myself and a number of my colleagues have been thinking about this for a number of years, and we're currently involved in a project around improving statistical literacy, reasoning, and thinking. And this is something that goes beyond academia, goes beyond research. In that statistical illiteracy, can have problems in the general public. If people don't understand numbers and interpreting numbers, it can be really bad for their health. And as the slide shows, there's research now on the doctor-patient relationship, and if patients don't understand what the medical doctor is saying, then it's difficult for them to communicate with each other. So just to outline some of the concept involved, statistical literacy involves understanding the basic language and tools of statistics. So if you don't understand what a mean is and how that's different from a median, then your statistical literacy is low. If you don't understand what a standard deviation is, for example, then statistical reasoning takes it up a notch. And now we're looking at the relationships between things. What's the relationship between central tendency and dispersion? So mean versus standard deviation, those kinds of things. And ultimately, statistical thinking is about knowing the limitations, knowing when to use one thing over not using another thing. Yes, it is deeper understanding of the statistical processes and methods, And ultimately, that's where we want to get people. But I would argue that in my field, there are a substantial portion of people who are still at this stage that they couldn't tell you what standard deviation is. And a standard deviation is so important because a standard deviation is used in the calculation for standard error, and a standard error is used in the calculation for a confidence interval. So if you don't understand a standard deviation and how that's constructed, understanding what a confidence interval does and how that relates to precision is going to be much harder. So anyway, I'll go past this bit. And there's been plenty of information from statisticians over the years about some of the statistical misinterpretations, and it's pretty clear that very few of us who are publishing studies in peer-reviewed journals know what we're talking about when it comes to statistics. You know, and some of these faux pas are just littered throughout the literature. And so I think it's pretty clear that our statistical literacy is, on the whole, is very poor, and might be even worse in my discipline compared to, say, psychology. But yeah, so, you know, this is kind of a call, you know, if we're going to, how does it relate to ethics? Well, you know, it does relate to the people who do the reviewing for ethics committees, you know, and the people on ethics committees. If they have poor statistical literacy and they're the one reviewing your ethics application, if they have no idea what power is, they're not going to ask the question. Okay, so we need to think about how we teach this stuff, and we need to focus on conceptual understanding. I believe using things like simulation, like that power simulation that I just showed before, and we need to teach statistical thinking, not statistical tests. And this is from the Gaze guideline. It really kind of solidifies what this is about. So in week 1 of carpentry statistics course, we learned how to use various kinds of planes, so summary statistics. Week 2, we learned to use different kinds of saws, hammers, confidence intervals, types of wood tests. But I wanted to learn how to build a table, collect and analyze data to answer a question. And I never learned how to do that. And unfortunately, that's what most of our research design and statistics modules are like. You know, they're testing tests. They're not testing what the construction of a standard deviation is. You know, what does a sampling distribution look like? You know, if you're doing research and you're taking a sample, you should know what a sampling distribution is, because that tells us about the variance from one study to the next. If you're doing studies where you're generating a p-value, okay, then you need to understand what frequency long-run statistics is all about. Or if you don't understand, you know, the differences between frequentist statistics, the probability of the data given the hypothesis, or in Bayesian, which is essentially the opposite, probability of the hypothesis given the data, or the relationship between power and sample size. These are all part of statistical reasoning. You know, they're the next step up from literacy. Okay, that's that paper on differences between exploratory and confirmatory studies that I talked about. Have a read of that. Okay, red team review. This is another one of Daniel's ideas, and I'll quickly go through this because we're out of time. But basically, it means you recruit your best critics, you know, and essentially we need more review, not less review, and that's part of the problem, I think. Robust review. Publish fewer higher quality studies. Too many studies are being published, not enough reviewers to review them. It's part of the problem. Register reports. I'm running out of time, so you can have a look at the slides at a later date if you're interested in register reports. But I think register reports are one of the solutions to our problem. Sorry. Okay, so poor methods and statistical illiteracy are common across disciplines. A poor method, including a statistical plan, is, in my opinion, as stated in ethics policies, an ethical issue. Researchers have a responsibility to ensure the research is robust, replicable, and don't waste limited resources. And ultimately, that includes the people you recruit. And ultimately is able to answer the research question posed. And that's the most important thing. If it doesn't, then I believe that's unethical. Use open research. So do you have a formal process of internal peer review as part of your ethics review or as a separate methods review board? Ethics policies need clarification of what is expected of reviewers. If a poor method is an ethical issue, ethics review should include methods review. And yeah, so that's pretty much it for me. Thanks for listening. And if you've got any questions, be happy to take them.
Thank you very much, Grant. That was quite thought-provoking and actually gave some ideas for my future talks. I've always started thinking who else I could invite. So we have a question from Billy. Actually, it's yeah. So I will just read it from the screen. So, what's your take on this ethical issue? The scenario is that terminating the data collection prior to the planned sample size, as reported in a pre-registration, after interim analysis. If considering negligible effect sizes, eta square 0.001 bias factor in favor of the null, and further data collection would require more than 6,000 participants to get a significant effect. It can be argued that researchers have an ethical obligation to hold data collection when it becomes evident that not even the smallest effect is present, as continuing would waste participants' time and taxpayer resources, ?
There's a lot to unpack in that. I guess most people would say it depends on what you've put in your pre-registration. Most statisticians would argue that what this is called optional stopping is not great because of how the p-value bumps around from study to study. You know, if you happen to do that early, you know, you do that interim analysis and okay, it's p equals 0.03. Okay, let's stop. There's incredible bias in that process. But the counter to that is if you've planned for sequential analyses, and this is something that Daniel Lakens has written a paper on, which I would encourage you to read, you know, you can plan in your interim analyses, and that's fine because you're adjusting the p-value to take account of those early peaks at the data. So it all depends on what you've planned. If you haven't planned to do it, if you let's say you've argued to sample 500 people and you're expecting a I don't know, you're expecting a medium effect size, and it turns out that after 100 people, either there's literally no change or there's a massive change. I guess you could, there is an argument there to say we might need to look at this. I would probably say you probably need to go back to the ethics committee and say, what is your thoughts on this? Because I suppose that there's two sides of it. There's the data side, the statistical side, and then there is the kind of the burden side. But I think you'd need to have really good evidence that there is no effect or there is a massive effect. But of course, that depends on how you've planned to analyze the data. So they are interlinked. I don't think you can separate the two. So if you haven't planned for interim analyses in your pre-registration, then you probably shouldn't be doing it. If people are dying, if you administer some drug, for example, and you want to administer the drug on 500 people, and the first 20 people you recruit all die from giving them the drug, you know, clearly there's an issue there. but you would hope that there's been pre-studies done on the, on the toxicology of the drug to stop that from happening. I hope that's kind of addressed it somehow.
Yeah, Bill, thank you very much, Grant. Bill, Billy, let us know, please.
Being disabled as
There's something. Yes, please,
criteria.
Catherine.
So I'll jump in. I dumped the reference in there because I thought that might be useful to people. Thank you, Grant. Really lovely talk. So clear, and has actually made me think, oh, I must go back and talk to my student who did a pilot, and it was deliberately a pilot study, which we actually massively over-recruited for, but but equally, I need to go back and go, right, we also need to put in effect size and confidence intervals to make sure that everybody's really clear about what we did find within that study. But that was deliberately exploratory, etc. So pilot studies, very valid, particularly in my zone of clinical area where burden upon patients is something we have to really take very seriously. But I think part of this discussion could be widened out just a little bit to really consider who are we having in that sample. It's not just a matter of numbers. The vast majority of research, particularly within clinical research, is on white, middle class, well-educated, well-financed, usually fairly adherent, and usually monodiagnosis. In other words, they just have a singular diagnosis, which is not at all reflective of our usually elderly, complex, multi-disability, polypharmacy populations that you actually see in your clinics. And as a result, we end up with a lot of data saying, yes, this pill is better than a sugar pill. And you have your entire patient cohort going, and it only works if, of course, you're under 60 male, not pregnant at the time and all the rest of it. So, I think we do need to be thinking about the who are we inviting. And one of the major biases that is still within clinical research is that you don't invite disabled people into your clinical trial. And I'll say that again because it is as mad as it sounds. We actually exclude, for the majority of times, anybody that is disabled from clinical trials. So yeah, I think this problem of the research itself having a valid construct, the methodology, I totally agree. I do think it is an ethical issue. I do think that if ethics are going to ask me about my adherence to the Data Protection Act, they should ask me as much about my adherence to the Equalities Act. It's just as much a legal requirement. It should also be asked about. So I think that this is a really interesting area for us to get our heads around, but also to get our heads around how to practically support in our researchers and our researching students to do this in a manner that is achievable within the workloads that we have. Because I must admit, my heart sank of you saying, oh, we need another methodological review panel. As a researcher, I'm going, oh God, not another thing to barrier to hurdle, but also the time, money, and particularly the staff time to run that really would be very, very challenging. Certainly within our faculty, we do pre-register the vast majority of our research of all varieties actually nowadays. And that is incredibly helpful, and it is very, very much improved, I think, our transparency of what we're doing and why we're doing it, etc. But equally, I think we do have to keep this. It has to be manageable. I don't know what the solution to the manageable versus the quality aspect is, but I do agree that numbers are important. But I really would just like to highlight that who we invite is also critically important. And NIHR have just put out a mandatory requirement that all of the research they fund now has to have a specific agenda around recruiting underserved communities to address health inequalities, because it is that serious. They've actually made it just across the board, no matter what you're doing, where you're doing it, how you're doing it, you have to have thought about your population so that we don't end up with this homogenous bias in our data literature, which has led to some quite horrendous outcomes in some cases.
Yeah, I mean, it points to the very basics, doesn't it? Of PICO.
Yes.
What's your population? And
yeah.
we see. I can't remember if I've seen a paper on it, but the number of papers that don't state who their population is.
Oh yes,
It's
absolutely.
just,
Or have very poor demographics, so you have a very limited granularity, and you might as well say, "Oh, the well and the unwell," or the elderly and the younger.
yeah. I mean, I think it's basic methodology.
Yeah,
Who is your target population and what are their characteristics, and you need to define who those people are, and then make your sample representative of those people.
yeah,
And one of the problems we find, and we see this a lot, where you have sub-analyses. You might have 1,000 people in your sample,
yes,
but when it comes down to condition X, you've
yeah,
got 5 people,
yes,
and then you've got massive confidence intervals, and that's underpowered and imprecise. And then they're making claims about that subpopulation of your bigger population, and that's where the issue is. But I think it's just basic research design, that you know who your population are, and you have to have a very good reason to exclude people.
yeah,
So
yeah, absolutely.
by default, everybody is in, and then in your population, that's the point of defining the population, and then everybody in that population is in, except for these people, for these very good reasons, and
Yeah.
then they're excluded. But yeah, Kate, you had a question.
Thanks, Grant. Just to let you know that I'm the chair of the University Research Ethics Committee, so I really wanted to come and listen to your talk today. And we've got another person who's one of our school ethics chairs in. So I think everything that you've been saying, I think we would definitely agree with in relation to research design, and we do try to emphasize that in our ethics review process across schools and at the university level. But I think in the real world where we exist, and you kind of mentioned a couple of them, that it is challenging in relation to what our committees are expert in being able to kind of critique on that kind of really minutiae kind of like level, in particular related to kind of more quantitative studies. I do think we have a dearth of skilled researchers in this area across the board. I think some areas really have a lot, but not across all schools. But I think the point about being able to kind of critique research design and then make ethical comments related back to that is really important for us. We know that we do get backlash from that at times, kind of like stay in your lane, please type of questions. And like I'm like, fine, that's and that may be true in some cases. So I think for us it's a balance about the questioning we have about the research design, and we do have a number of questions on our ethics form that really try to understand exactly what is going on and the specifics of who you're collecting and why you're collecting a particular number from a particular group. I mean, it's not perfect, but so we do try to emphasize that. But I guess I can understand Catherine's point of view about having another layer to concern that we already have on our ethics sort of committee. In particular, we have a big sort of move towards like AI and how do we manage all those sorts of projects and the levels of expertise we have at the university. So I just say that I think your points are really relevant, and I would definitely agree with them that I think design is an important ethical question, and we shouldn't be just asking people just to do stuff just for the sake of it. I suppose when we look at our whole gamut of researchers, from our undergraduates all the way through up to people who work in research centres, I guess the expectations of being able to do some research, that they can get some of the skills in order to do that, then perhaps limit some of those aspects that we would ideally like from more of our grown-up researchers that we would expect to really kind of see. So I guess for us, it's about, I'll definitely take that forward though, about emphasizing the methods a little bit more in some of our policies. I can see a number of times where we mention research design. So for me, that would include specifically those types of elements. We also have our people, culture and environment meetings at the moment for REF, which look at around research integrity and ethics. So I can certainly bring that to the fore as well, about how do we go about trying to ensure this level of transparency is already kind of important for us, but in particular in relation to what you're talking about, which is more of like those quantitative kind of elements, that's in there too. So we can open up the conversation with other people who aren't in here today. So just to thank you and let you know that yeah, we do think about these things as well.
Yeah, great. Thanks, Kate.
Thank you.
Yeah, I mean, the burden of another layer is there, and That's something that even Daniel Lakens, I think, acknowledges. My approach to that is really about the improving the individual, in that we wouldn't need a methods review board if people had high statistical literacy and design literacy, and they could think about these issues before they submitted their ethics application. And I kind of agree with what Hull said, is that, you know, you should be doing this stuff before you submit your ethics application. You should be getting that peer review, that robust peer review, trying to poke holes in your method, your questions, your hypotheses. All of that kind of robust stuff should be done before submitting your ethics application. But we know that it doesn't happen because of the quality of applications that, certainly my N of 1 experience of reviewing ethics applications, it was clear that the people submitting them had very little idea of what they were doing. And so the methods review, I think, is a sticking plaster over an issue that should be about your own personal responsibility as a researcher. That's not to say that all of us should become statisticians, but, you know, when we publish that study, our name is on that paper, and we need to take responsibility for all of that. And in my field, certainly, most studies don't have a statistician listed as an author. And so it is about accountability. And, you know, I just believe that research design and how you analyze your data should be at the heart of what every researcher needs to know about. You know, in my field, there's basically 3 types of researcher: physiologists, psychologists, and biomechanists. And most of those people focus too much, I believe, on the physiology, the psychology, and the biomechanics, and not on the process of doing the research. We see this in papers all the time. Their explanation of how they collected the data, you know, the muscle biopsies they took, whatever, is intricate and detailed, and they clearly know their stuff. But when it comes to the basic research design, it's very poor. And like I said earlier, I do believe that universities have a role to play in how we teach those things, because the students of today become the researchers of tomorrow. But in the project that we've been involved in, looking at how research design and statistics are taught in sport and exercise science programs, it's pretty basic. You know, it's based on testing rather than those things of integration of knowledge, concepts. And I just think that's a gravy train leading us. That's the gravy train that's led us to the reproducibility crisis. And that's out of the scope of ethics committees, of course, but the people who are sitting on those committees and who review for those committees are those people who weren't educated, I believe, appropriately. And so it's kind of, you know, it's this circular thing. You know, I don't know what I'm doing. I'm going to submit my application, and the person reviewing my application, they don't know what they're doing. So, you know, nothing changes. So anyway, it's a big problem, but
yeah, I'm a bit mindful of time. So we have one question from Victoria. Probably we could take this question and then wrap it up.
Yeah, thank you for the presentation. Really interesting. I am probably quite an anomaly in the School of Education, because I am the quantitative, or one of the very few quantitative researchers. I am a psychologist as well, so I kind of hit the nail on there. But I guess what I'm thinking is, you know, we have tried, and as Kate said, we have tried to build in this kind of methods idea into ethics review. And she's right, it is really, really challenging because of the way that people come back at you in terms of your review and the comments. And I don't know how to change that, because I think it's more of a wide, whole scale changing of how people view this. And so one of the things I guess we're trying to do is build that kind of bigger research integrity idea, that this is about the quality of research. It's about that kind of aspect. It's not about, and I guess, you know, some of the words that we get used when it comes to ethics is it's a barrier, it's a hoop to get through, and those kind of things. And actually this idea that ethics is an embedded part of your research design, your research process. So all of those things are coming together. I think until we can change the thinking around that, I think it's going to struggle kind of work at the other end. And then I just one of the things that has been kind of just came to me as you were also talking is one of the things I've seen come up in some of the psychology literature over the last few years is the idea of marginally significant results, which was a whole new kind of phrase to me. And I read it in a paper and I was like, whoa, where did that come from? So they've added in this other kind of grey area now that we're starting to see a bit more of. And so that to me creates an even bigger issue when it comes to people looking at, you know, what studies are, because quite a lot of people look to what's in the literature. And that's why I think your talk's really interesting, this idea that, you know, actually you need to understand what you're looking at in the literature to know whether or not actually you should be following that literature. But there's almost the assumption that because it's been published, we're good to go. So yeah, just really, really interesting. So thank you for sharing with us.
Yeah, no problem. Yeah, it's we're not going to solve the problem with a 1 hour talk on a Monday afternoon, but and a lot of these issues are structural across mostly academia, because I get research is published by academics, and those incentives that I talked about, or perverse incentives that I talk about, are really powerful drivers, you know, and the metrics that are used are pushing us towards, you know, fast and quick when we actually need slow and considered, you know. And I've often said to my colleagues, you know, what would you prefer? You over a ref cycle, you publish one study that wins a Nobel Prize, or you publish 100 studies that don't? You know, how would that be viewed in an institution? And well, I don't know is the answer. You know, and it all comes down to why we're doing research. And I believe, you know, somebody who's now outside of academia, at least temporarily, that a lot of these problems have been accumulating for a long time, but they've been exacerbated by the competitive nature of academia, and the race that's ensured. And I you know, there's a good argument, you know, if an ECR says, well, I need 20 papers on my CV to get a job, you want me to do a registered report that's going to take me 2 years. My colleague down the hall, they've published 6 papers already. What do you say to them? You know, I can say till my heart's content that, you know, focus on quality, focus on the long game. But if you can't eat because you don't have a job, that's a real problem, you know. And so at Hull, myself and the institutional lead were working on promotion criteria as one of the mechanisms to try to, you know, change that behavior, I guess. That and of course, you know, there's a lot of debate about these things across academia and how they're bad for research, how they're bad for society. But unfortunately, they're very difficult things to shift. But that's why I argue, at least if you think about your own work and your own literacy, then there's nothing stopping you from improving your literacy. And you know, even if the systems can't change, or they're taking a long time to change, you can improve your literacy. You can do a pre-registration. You can do a registered report. There's nothing to stop you from doing those things as an individual, and that's really all you can do, I guess. Or if you want to become part of an ethics committee, you know, become part of the system and try to change it from within. But you know, that's a long-term prospect.
Yeah. Okay, thanks very much. That was very, very useful. As you can see from the comments, also insightful. I will contact you separately offline for sources on uncertainty measures, because as part of my role, I'm also raising awareness and literacy and literacy. So it would be interesting to get something that I could share with my on our accounts. But otherwise, thanks very much. It's been a pleasure, and it's been great to see so many people engaging with this relevant topic.
I'll send the slides through if you want to circulate those.
That would be great. Thank you so much, Frank.
Thank
Okay.
you. Bye.
Thank you.
Thank you. Bye-bye.
Bye. Bye.